morning, friends. So today we will seeing a question from Leetcode, that is maximum level sum of binary tree. Now the question that is given to us, that we will be given a root of a binary tree. The level of its root is termed the level of the root, like the from the tree where it starts is termed as level 1. The next level will be 2, then 3, then 4, then 5, then 6, and so on. Now what we need to return? We need to return the smallest level, like 1, 2, 3, smallest level, such that the sum of all the values at the level x, let's suppose sum of level 1, the sum is 1, of level 2, the sum is 7, of level 3, minus 1. So we need to return the sum of all the values of the node at level x, its maximum. Like we need to return the lowest value of level for which the sum is maximum. So this is our question. I hope the question is clear to you all. It is pretty straightforward. Okay, coming to the explanation or the approach part, what we can do, we will be having this kind of tree. Basically, we have 1, 7, 0, 7, and minus 8. Simple BFS approach. But before BFS, let's just talk about DFS. Can we do it with DFS? The answer is yes. How? What if these are the nodes? I can go in depth, and while going in depth, I can tell that it is level 1. Doing a DFS call plus 1, doing a DFS call plus 2. I can go and plus all the levels. Now for storing, I can use a map data structure for storing key values like level 1 sum is something, level 2 sum is something, level 3 sum is something. Now as soon as I go here, what I will be doing, initial values of everything will be 0 by default in map. So I will be doing sum plus root value, then value, then value. Let's suppose I go over here, I returned over here, went over here. So now 7 plus 8, because this is level 3, this is also level 3. Now 3 will be first 7 plus minus 8. Like this you can do with DFS. But in DFS you will be requiring a map, and you will be doing all the recursion call, which is again the stack memory, heap memory, recursion memory basically. You need this. So we will not be going towards DFS. We will be going towards BFS, the most optimal approach. Now in BFS, let me just remove this. Okay. So in BFS, what we can do? A BFS is normal traversal for 1, 7. I will be going towards 1, then 7, then all the tree, and all the trees over here, then all the trees over here, like this. Simple. I will be storing it in a queue and adding them level wise. This will be a basic approach to solve our problem. A basic BFS through which I will be going toward every level, submit. Now I can store every level sum in a vector. Vector starts with 0, index starts with 0, 1, 2, and 3. So we will be having, if I want to return the level, I will be just be doing index plus 1. Or what you can do, you can start adding values from 1. That is also possible. I hope this is clear to you all. We can use a vector to add. Now vector will be taking O n space, and BFS will be always in a loop. So there will be no extra memory, stack memory or something like that. We will, and traversing to every element will be On. So the space and time complexity will be On. Whereas in DFS we were using map and there was also a recursion stack. I hope this is clear to you all. Explanation thinking part is nothing. Let's just see the code. Now I will be taking a vector, long, you can take cube for storing the basic BFS we already know. Sum, now the size we will be taking and then traversing it, inserting left and right and then pushing the element in the sum. Now after I will be calculating the maximum element index and then I will be doing +1 because this index of a vector starts with 0. Let's just try to run this and let's just submit the solution. Okay, we got a correct answer. This was a basic question with DFS. Oh, sorry, with BFS. You can do it with DFS, but DFS will taking more space and more time. If anyone has any doubt in the question or any approach, you can try to write in the comment section. Or if anyone has any better approach or better idea to discuss, you can also write in the comment section.